With that said, we can talk about diagnostic and testing. We're going to verify the condition and state of charge of the battery. We're going to verify condition of mechanical systems. We're going to test the alternator for output for voltage and amperage, and then we're going to check any trouble codes and make sure we diagnose those accordingly. Here's some of the tools that you'll probably need to do this, which most of these, yep, there you go. I gave you guys the belt tool already. That's one off the list. Most of you have a scan tool, correct? It's pretty much standard issue now for any shop. DVOM, it's great to have an amp clamp. Very good to have an amp clamp. A battery tester, you can use a carbon pile by loading it down to the half of the CCAs of the battery and watching it for about 30 seconds. It shouldn't drop below 10.5 and 9.5 at the very least, but then it should recover back to the original voltage. The reason I say that about the battery testing equipment, because I've seen some of the handheld ones that'll fail a battery that will pass on most other equipment. So just be cautious there. But with that said, the battery is always always guilty until proven innocent. So the battery is always guilty until proven innocent. Make sure the battery is at least 12.4, because the state of charge of a battery is ultra important when you're doing any kind of electrical testing. 12.6 is 100%, 12.4 is 75%, 12.2 is about 25%, and 11.89 is 0%. So if you have a battery with 11.89 in it, it's completely discharged. Think about a 12-volt system. You would think 12 volts was fine, but it's not. So you won't be able to get any viable testing unless it's at least 12.4. But you make sure it passes a load test and make sure that it passes a capacity test. Oh yeah, here's the nice one too, right? They always come in like this. Not. I think that came off a brand new car. It must be. But, yeah, but when you look at this right here, even that amount of corrosion right there on those cables, it's super important to get rid of all that, because on these newer systems, just the smallest amount of voltage drop, which I'll go through voltage drop here in a second, can cause a great impact on the performance of a charging system and the longevity of a charging system. Verify your connections. Now I know this is an extreme picture on this one, but let's think about what else should you replace on that picture if you've got that vehicle in. Yeah, the whole cable. A lot of people will say, oh, I could solder a new end on there, because this thing's been pressed on there like 20,000 pounds to crush it, to get every single cable, every piece of copper used in that cable. You don't have that equipment, I understand that, but you couldn't solder that on there either, because guess what? That's got so hot that it's melted down by that post from being loose. Yeah, that too. It probably would melt the solder off it, because what's happened is you can take that cable, and it's gotten so hot, and you move it back and forth and you'll hear it cracking. It's because that copper got super, super brittle in there and it's broken. And now, like he said, if you soldered it on there, when you put amperage through there, what little copper that's left, because you just reduced the cable size, is going to get superheated and it's going to melt that solder right back off anyway. So yeah, you got to replace that cable. And it could do worse than that too, because it'll light that whole cable up. Okay, so simple stuff. We check our battery. We check our connections, we go to the back of the alternator and we make sure that it has battery voltage at the back of that post. If there's not battery voltage there, that regulator can't turn the rotor field on. Because remember earlier, it pulls the B+ to the rotor to activate it through a B circuit. And we want to look at our front end accessory drive. Starting with the belt, because alternator under a load takes up to 10 horsepower, 5 to 10 horsepower. Some of these 215 amp units take more than that. I mean, have you guys ever seen one on a test bench? You put the alternator on the test bench, and the electric motor that has no power curve, it's just straight on or straight off. You kick it on with a loaded alternator, and you'll just hear that belt squalling, because that thing is heavily loaded. It takes a lot to turn one of these. With that being said, what turns it? The belt. Which one of these belts is bad? Kind of a trick question. I know you guys probably know that. They're both bad. Yeah, there's a difference in the belts. The top one is a polymer. That's the old style belt. Polymers or poly. Poly means many chemical compounds. They'll tend to separate from each other and they'll cause cracks. So in the past, everybody was used to looking at this. And the reason this is important to you is that your customer is going to look at that bottom belt, which is the ethylene propylene diene monomer. Mono means one chemical compound. Even though it may crack over time, it's not going to crack like that top one is. Usually what happens to those are the ones that you get your needle nose pliers out and you start pulling out of all the components because it finally shredded apart because nobody changed it because it looked good. And that's the way your customer is going to look. And that's one of the reasons I handed out that tool today to all you guys, is that you'll put that tool in the belt. And when I say the belt, when you order an alternator that has any kind of miles on it, order a belt. I don't sell belts. I don't get bonused for it. But buy a belt. If the customer doesn't buy it, you can send it back. Show them the difference in the two belts. Show them their belt, put the light behind it, and show them the new belt. Not only that, you might increase your sales. You're already in there. It's not going to cost them anything more than the additional cost for the belt. Put that tool on there and shine that light behind it and show them that. Here's the tool. And this window is used for looking for the cracks. And you guys ever see the toothpick one where you put it down into the belt and you feel across it, like this one here? That's what this little blue line's for. So it's got all three in one. And the reason I prefer that blue one is because you can physically see that. The customer, it's more impactful to them to see that light coming through there. Also, a lot of times these are overlooked. Belt tensioners and idlers. If the idler's bad, or if the belt's bad, or if the alternator's bad, guess what? All of these components are designed to last the same amount of time. And these are sealed bearings. It's not like you can go in and re-grease them. Some of them you can take the pulley off if they're the metal pulley and replace in a 203 bearing, but I'm telling you, if it's worn out, replace it. If the idler's bad, the tensioner's not far behind, or vice versa. So, important to the tension because 5 to 10 horsepower, right? And talk about V-belts, let's talk about the different pulleys. The V-belt itself, that's fine for 37 to 63 amps, but if you get much more than that, you need to spread the load out, and that's why they came out with the serpentine belt. And then Chrysler came out with a 3.3, 3.8 minivan that when you drove through the water and the alternator was loaded down, it threw the belt off. You guys remember that? Yeah. Neons did it too, yeah? Your wife's car does it? So, if you look at the pulley that they came up with, and let me explain why they came up with this pulley. The crankshaft moves one time for every 3 times the alternator moves. So when you load that alternator down, that thing's spinning faster than the crankshaft, and it's now pushing the belt towards the alternator because they put it at the back. So it's pushing the belt toward the alternator, and it's pulling it from the other side. So guess what the belt wants to do when you load that alternator down? It wants to overrun it, absolutely. Overrun. That's why they call it an overrunning alternator pulley. Now the problem with this one is that look at all the moving components. Look at all the sprags in there. You guys ever hear one of these come in when it's bad? First one I ever did was on a Mitsubishi, which was a Dodge product. And they had this pulley way back. I don't date myself, but when it came in, I was prepared to do rod bearings on the car. It sounded like the whole bottom end of the engine was coming off. So I thought, well, let me make sure it's not the harmonic balancer doing something stupid. So pulled the belt off and it started up, it was quiet. Oh, there you go. Started looking at the harmonic balancer, nothing wrong with it. It's like, what the heck? So I pulled the alternator off, moved both ways. These things are designed to give in the drive direction, and then when the belt stops it, the rotor mass, the centrifugal force, spins to a stop. Keeps them from chunking belts out too. If you rev the car off and rev the car up on some of these and turn them off, you instantly hear the belt chirp because it's taking a chunk out of it. Here's what we use. Here's my sales point for the meeting, right? Because I know it's a technical meeting, but we only use these because they're tuned to the pulse vibrations of the motor. Sounds like science fiction, I know, but that means it's half the cylinders times the RPM. It's got a spring in here that absorbs the noise and the vibration and the harshness of the motor. And when I say it's a pulse vibration, because the cylinder fires before top dead center, it has a slight rock back before it continues its path. And you'll see it if you've ever timed a small block Chevy or on the high side on an air conditioner. And what this thing does, it actually absorbs some of that vibration so it makes the engine run smoother. And the reason that these are important is because they're always put on these component drives that are far away from each other. So if there's long expanses of belt, they put them in there. Not necessary for some of them. If it doesn't have it on there originally, don't need to put one on there. But the difference on these is that they got a 4, 6, and an 8-cylinder one because half the cylinders times the RPMs is what causes the vibration. So at this point in time, we checked our battery out. We've looked at our belt drive system. We've checked our connections, made sure we had voltage at the back of the alternator. So let's do something even simpler. Let's turn the key on and look at the dash. We should have a battery light illuminated. If we don't, and this is on all systems, there's very, very few of them out there that have gauge only. And I'm talking about even the lamp-driven ones. So look at your wiring schematic on those. But on the newer ones, definitely, you turn this key on, that light should light up because it is a check engine light for the system anyway. So if that doesn't light up, you need to check your fuses and then find out why the fuse popped and repair that circuit. If you start it up, that light should go out. If it does not go out, then you're going to have codes. Let's talk about the codes. B1516, battery current sensor performance. And we have B1517, which is battery voltage. 1527, high parasitic load detected. This is that deal I was talking about earlier where it's looking at the amperage. System voltage low is 562. 563 is system voltage high. 621 is your L terminal, which is your on command. There's a communication problem there or a wiring problem. And then 622 is your F terminal. Well, let's talk about these real quick too. You ever see the 0 in front of the numbers and then the 1? The difference is the 0 is a generic number and the number 1 is a manufacturer-specific code. This means that 622, 621, 562, and 563, all of those can be used by any manufacturer, but it has to say the same descriptor. It won't say the exact same words. Like Ford, it says gen monitor and generator communication. So it'll say GenCom, GenMon. Well, that's on in the monitor. This is L and F for GM because L is the on and F's the monitor. The 1 stands for manufacturer-specific code. That means that if it's got a 1 in front of it, it's only for, in this case, GM, to use that descriptor for that number. So hopefully that narrows that down. B1516, battery current sensor performance. We got 5 volts on one wire. We've got a variable duty cycle coming out of the middle and a ground on the other wire. Should be able to check those. If you clean the plug-in, put it back in, and that code doesn't go away, look to make sure you have 5 volts on one of the wires, verify a ground on one of the wires, and you'll see it on your wiring schematic, and then look for a duty cycle coming out of the middle. If you don't have the voltage coming in, it may not be the current sensor. If you don't have a ground, it may not be the current sensor. But if you have both of those and no signals coming back out to the BCM and the pigtail's intact, it's probably the current sensor. And if it is a current sensor, put it on the same way it came off. Most of them have an arrow, some of them do not. So just mark it and put it back the same way. Because if you don't, look what happens. So you go in there and you do all this diagnostic and you find it's a battery current sensor and you put a new one on there and you start the car up and the code comes back up. What do you think first thing? I got a junk part, or you're upset. Especially after pulling that cable all the way off to get it off of there. And it turns out you might have put it on backwards. So be careful of that because I've had several people in class that prior to their coming to this class, they had done that. 1517 is battery voltage. Now this code itself, there could be a couple things going on here. We could have a bad battery or we could have some voltage drop situation going on. But if we've tested our battery first things first, then more than likely we would have already caught this. If not, if we've changed the battery out and this code's still up, we want to do some voltage drop testing.